Hi, it's really awesome to be back and to talk to you guys about, quite frankly, a journey that I've been on as a developer over the last couple of years. And sort of what happened was, for a few years, I disappeared off into server land. Did a lot of work with Python, Twisted, Tornado, hardware stuff. Actually, later, if you want to stop by the Influxus booth, we're showing some really fun IoT things that we built together. I'd love for you guys to come check that out. And I did some front-end stuff. My company, built some simple front ends in HTML and jQuery, and we're happy with things. A little bit of Backbone. And then we managed to get involved in a really neat project. It's called Space Forensics. And what this is it's a government contract. We had to go through this huge process. It took months and months. And it was for an educational, LucasArts style, like Scum VM game for NASA. Yeah, this was a total geek dream come true, but it had to run in the browser. And so we had to get our JavaScript chops up quickly to make it work in everything we wanted to make it work with. And so we really started to dip our toes back heavily into JavaScript, and it was sort of like, what in the hell happened? Everything feels like it changed out from under us. And it felt like modern JavaScript was suddenly just utterly crazy-making. What started as a small, poorly named scripting language from Netscape is now this monstrosity. So much has happened so fast, it's really, really hard to evaluate. You go find a blog post about something, and it's like instantly dated. Now, I'll still give you some recommendations, the path that we went down for building out some of the things that we built. But more than that, this talk is about teaching you how we went through our evaluation process to figure out what we were going to build and how we were going to build it. Now, the tool chain I'm going to be getting into that we have chosen was for actually a different project. For Space Forensics, we ended up having to mostly build custom stuff. But now that we're back and heavily involved in JavaScript, we're finding these techniques. We have to use them constantly. Basically, every project, we're reevaluating what our tool chain is, how we're using libraries, how the pieces fit together, because we have to. Now, to understand why everything's the mess that it is right now, you have to understand how we got here. Now, there was a little bit of an inauspicious start. 10 days. 10 days, made a programming language. It was named Mocha, then it got renamed to LiveScript, and then JavaScript, which still hurts my head. I still have to, like, oh, I'm learning JavaScript or Java. They're like the same thing, right? How many times do you guys still have to deal with that? Yeah, not a lot of fun. But then it started to become a standard. You had ECMAScript v1, which defined the standard. And then v2 made it an ISO standard, so it's standard twice over. And then v3 is the first modern JavaScript. And you had regex, you had try-catch, you had a lot of stuff that made that massive book, JavaScript, the complete guide. Note, 1999, okay, this is important here, because then there was the power struggle. Plugins started to become a thing for non-trivial interactivity. I was a Flash guy. I'm mostly reformed now. But that's how you had to do it, was Flash and Java, because there was only so much that you could do with JavaScript. There were very hard limitations, let alone all the hard edges between the different browsers. And there was these huge fights over what was going to be the future of JavaScript. There was not one, but two aborted attempts at making v4 ECMAScript. The second one you guys may be familiar with was ActionScript 3. ActionScript 3 was going to be the future of JavaScript. And there was this fight over the soul of JavaScript, and standards were made, and versions were made, and Microsoft and Yahoo and Macromedia, they're all fighting. And basically, after a long time, version 3.1 got made, which got renamed to version 5, and that happened in 2009. 10 years. We lost a decade of JavaScript there, okay? And that's, quite frankly, why Flash happened. Had the companies managed to get together and figure out things, we would have progressed probably a lot faster and a lot better, but instead we had this entirely lost decade. But it was a fight for the soul of JavaScript. And as much as I was a Flash guy back then, now I believe that the right side won, where it's actually more functional than it is sort of strongly typed OO. We'll get into that, though. In the meantime, while all of that's happening, in 2005 you have the Ajax white paper. Never has a single function changed the shape of everything. XML HTTP request. We'll just ignore the XML part. Just, no, that wasn't a thing. And back then, before this point, the thing you had on your resume was DHTML. If you knew DHTML, you were hot shit, right? You were dynamically changing the browser, and you had to make it work in Netscape, and it was a thing. But the Ajax white paper came out, started to become a thing, grabbing data in the background. Us people who worked in Flash were not terribly impressed. It's something that we did going back to like version 4, but it became a thing. Then jQuery and MooTools and Prototype and Dojo start popping up. They make working with the DOM easier. They take the poorly crafted, I would say, DOM APIs and make them easier and more functional. And smooth over the cross-platform issues. And they bring some really great common development patterns to JavaScript, chaining, observables, promises, all of these neat ideas. And suddenly, JavaScript was being used to fix the potholes in the web platform. It was not just like extending itself. They're using it to fix problems with HTML, problems with CSS. It started to build to be this more powerful thing. And then Node happened. And JavaScript escaped the browsers, like the velociraptors from Jurassic Park. It's like, oh God, JavaScript got out. Node.js came out, and I mean, I'd seen this pattern before. PHP actually did this. There's command line PHP, and it's like, yay, we have JavaScript another place. Okay, I don't get it. It's not really my thing. I'm not really into it. But it was powered by Google's V8 engine, the thing they had open sourced, and it was very powerful. It was very fast. It had asynchronous I/O. Again, not super impressed, because I've been doing that in Python for years. There's a really great library called Twisted for building servers and doing this stuff. But like, hey, cool, it's in JavaScript, and you can take a language you know on the front end and now use it on the back end too. And that brought JS on the server. But I'd actually say that the biggest thing with it was anywhere, because now it's a huge part of the tool chain of everything in JavaScript land. The promise was JavaScript on the server, but it's actually been a lot more than that. You can buy stinking single board computers now that just run JavaScript talking to whatever kind of sensor you can imagine. And then came the big thing, as far as I'm concerned, which is NPM, Node Package Manager. It made it really easy to make JavaScript libraries and publish them out to the world. And that resulted in what I'm calling the JavaScript Cambrian Explosion. Now, if you guys, I'm a geek, I like anything, fossil science, whatever. So 542 million years ago, there was this massive evolutionary boom. Tons of new creatures created. All the modern animal phyla were created out of nowhere, and it was incredibly fast. Just tons of stuff. Boom. The thing about that is, while all the modern animal phyla came out of that, there was a lot of stuff that doesn't exist anymore, like almost everything in this picture, right? When you have these huge evolutionary bursts, it's exciting, it's amazing, it's a hot mess. And that's exactly where we are right now. If you go look at JavaScript modules, on NPM, as of yesterday, that's how many there are up there, okay? That's a ton. I use PyPy in Python. I've used Hex with Elixir and Erlang, and JavaScript is absolutely wiping the floor with them. It's humongous in comparison. The thing is they made it really easy to publish to NPM, but there's basically zero gatekeeping. There's massive overlap. Lots of people have written the same things again and again and again. The quality varies utterly wildly from just tiny jewels of amazing code to utter crap. And then there's lots and lots of dodos. There's lots and lots of stuff there that's not going to be there. You know, the joke is that we have in the office is you could need to go to the bathroom, and by the time you come back, a new JavaScript library has become popular, and deceased in that span of time. And it really does feel like that. And as somebody who wants to build things, and I care about the things I build, that's scary. It's just scary. And wait, I said modules, right? Yeah, note that script in JavaScript, there's no language support for modules, or there wasn't. So workarounds it is. You have CommonJS on the server, what Node uses. You have asynchronous module definitions for the browser. Oh, and by the way, yeah, they're incompatible. So you'd like to write JavaScript modules and ways of sharing and using JavaScript code, but it's incompatible between the pieces. This basic thing that we use in other languages for packaging up and sharing our code literally doesn't exist at a language level. There's no support for programming in the large in this language. It did everything totally freaking backwards, and yet it worked. I'm impressed. So what's the solution? More JavaScript. More JavaScript. They have JavaScript-based tooling that pops up. Things for scaffolding your projects. Yeoman, Slush, a whole bunch of things. You have transpilers. I'm sorry, you're compiling into JavaScript? CoffeeScript, TypeScript, Dart, Babel, ClojureScript, Elm, all of these different things. You have build tools, Grunt, Gulp, Webpack, Brunch. I think we have a problem with naming in the JavaScript space. It's fun, but it's, when you walk into this space and you're like, oh, we're using Grunt. When we first came into it, I had no idea what any of this crap is. Like, it's its own little secret language. We have to learn what all these terms are, and more importantly, what they do and how they relate to the other stuff out there. It's opaque at first coming into it. It sucks. And yeah, things get worse. It's getting worse because there's more things coming, and the steamroller's heading right towards us. You've got ASM.js. So it's a strict subset of the JavaScript language that acts as a compiler target so that things can be run damn near bare metal in JavaScript. So you can compile C and C++, Lua, Ruby, Python, whatever, to JavaScript, and it runs really fast in the browser, like really, really fast. You've got ECMAScript v6. We've got modules. We've got tons of new syntax. Lots of things that make JavaScript suck less. In ways, there's a reason why you had JavaScript Definitive Guide and JavaScript the good parts, right? Like there's a lot of junk in there, bad ways of doing things, not good patterns, not good ways of working with the language. You have web components, an emerging standard for defining reusable chunks of the web. There's a particular library out there called Polymer that is a polyfill for this that's out there right now. I'm not totally convinced on this yet. I've played with it. It seems interesting, but it still feels a little ways out for me. And then you have HTTP 2, which, yeah, everything you know about HTTP is wrong, which was a real kick in the crotch, kind of learning about how that works. Because a lot of the things that we do as we're compiling up JavaScript to minify it and put it in its own one file and all of these things we do there, HTTP says, yeah, that's not how you're supposed to do that. And I mean, I'm not an anxious person, but this makes me anxious. The state of how you have to work with JavaScript now makes me really, really anxious. And we're trying to build castles on sand. This stuff is changing so constantly that as someone who wants to build things, it worries me. I mean, there's really no other way to put it. It just worries me. It can be done, but you have to be smart and you have to be careful and you have to create a really tight loop of learning what's out there, finding out what exists, testing it, evaluating it, and using it. You cannot just sort of pick a winner and just run with it, right? If you're going to be using the newer stuff. Now, that all being said, a really important point here is one size does not fit all. I'm going to be talking about the current things that we're building for products, things that are going to last a long time, things that have a certain weight to them. So when you're evaluating what you want to use to build with JavaScript, you have to ask yourself these questions and not just go grab the new shiny. Now look, I like the new shiny. The new shiny is always new and shiny. You know, you can't not like want to try this new library, or this new language, or this new stuff. But at the end of the day, you really need to evaluate what you're building and why. So what are you building? How big will the code base be? This matters. Is it just a script? Throw jQuery at it, have fun. You know, what is the point of what you're building, and how long is it going to last? Who's your audience? You know, do you have to target IE8 people? Yeah, okay, well, you have different things you have to deal with. Are you mainly targeting mobile? Okay, size matters more. There's a lot of things like that you have to fully evaluate. What does your team know? And I think this is vastly underrated. When you're working with a team of people, there is the idea of a mental load. You know, you have to go and learn new things. If your team is already comfortable with a particular way of working, it might be better to use something that's not as popular, but that better fits with what your team knows. If anything you take out of this talk, it's to be pragmatic. I own a software company. I've got developers that work for me, and I still write a ton of code myself. And it's painful when I have to make those kinds of choices, but fundamentally they're the important choices to make. And then lastly, like, when is this project due? When do you have to have it done by? I love learning as I build projects, but if I'm learning and the project's due next week, that sucks, and you're probably going to screw it up. I love learning on other people's dime. Hey, it's great, but you have to be very careful with that kind of thing as well. Oh, and actually, lastly, how long will your code last? This is it's a hard problem, a hard question to ask, I should say, because when I go to build something, I always want to build it forever. I want to build, a castle. I always wants to be a great thing. But at the end of the day, a lot of our projects aren't. I build things that are marketing websites. You know, it's not going to be like, the Space Jam website that's still up? You know, most of them aren't going to be that. So figuring out what you're going to do with that code going forward. You know, if it's something where you're going to have to babysit this going forward in the future, you don't want the problem that government agencies have where they've got to go try to find COBOL programmers, right? Find something that is looking toward the future, if that's where your code's going to live. There's a whole thing I remember saying about how approximately 90% of the time spent on a particular software project is essentially maintenance. Keep that in mind. Think of how long is this thing going to live? The other thing about this is it's not just a technical problem, right? jQuery is pretty ubiquitous, and you can, swing a dead cat and hit 3 people that say they know jQuery. It's fine, but the fact of the matter is that the quality of libraries around jQuery is uneven because it is become this ubiquitous thing, and the quality of developers that say they can use jQuery is uneven. So while it's popular and a lot of people know it, that doesn't necessarily mean that you're always going to get good quality. The other thing is that a crappy code base is not fun to program in. Like, I don't know about you guys, I like writing software. I do this because it's really fun for me to build things. And if somebody hands me a crap code base to work in, it's not a lot of fun. I had to do a bunch of work a while back helping somebody unscrew up a bunch of old Visual Basic. Yeah, that sucked. That was not fun. We ended up basically like black boxing it, turning it into an API. It affects employee morale. Having a good code base and a good development cycle makes it nicer for everybody. I hope I never have to give up developing myself because I like being in the trenches and seeing what is good or bad about how we develop software so I can help to change that. It's important to me that my team feels productive because that's fun. Making stuff is fun. When you have that kind of flow state going, it sucks if you have to interrupt it because your tooling or your language or your libraries aren't enjoyable to use. And then lastly, it affects internal training. You have ramp-up time, and it matters. It does. You have to bring things on board that make sense to learn and how you learn them. All right. Now we get into this really, I mean, quite frankly, it's an embarrassment of riches where we are right now with JavaScript and these transpiled languages, where it's a programming language that gets compiled into JavaScript. And the quality of these vary, but most of them do a pretty decent job. The non-ASM.js one. ASM.js makes stuff that no human can read, and that's the point. It's made to run bare metal. But if you look at TypeScript, if you look at CoffeeScript, if you look even at ClojureScript, the stuff that they spit out is you can read it. It comes down to what you need, right? There's some strong pros here. You can get just the good parts of the language, really focus on the good parts and make sure that the bad parts aren't as easily accessible. You can add things like strong typing, improved syntax, and in some cases, some real domain specificity. So domain-specific language, like where it makes the language be wrapped around the kind of problems you're trying to solve, which is it's pretty neat. Excuse me. But there are cons as well. You do need to know JavaScript too. You can't escape JavaScript with this. It is a as well sort of thing. I would say that the language you're using matters less than the discipline of your team. If you write good, clean code, cool. TypeScript isn't necessarily going to make you do that. It helps you do that, but you need to be disciplined no matter what of these languages you're using. It's not going to solve that problem. There's going to be more complex tooling involved. There's another place where bugs could exist, right? And you need to acknowledge that fact. It does happen sometimes. And there's going to be longer ramp up because your team is going to have to know not just JavaScript, but also this other language as well. Now, where we go with it is ES6 and Babel. And what ES6 and Babel is well, it's the next generation of JavaScript, ECMAScript 6. And there's a transpiler called Babel that can turn it into JavaScript that will run in current browsers, ES5, essentially. We went this path specifically because we wanted to be sort of investing in the future. It solves a lot of the problems with JavaScript. Like, this is why the transpiled languages came to be, is because there are problems with JavaScript. Modules is one. There are many others. I feel like ES6 solves these problems well, and since it's the future of the language, writing stuff in ES6 makes sense. We're writing something that's going to be supported going into the future. It seems, in many ways, is the sort of the low-cost bet. It solves a lot of problems and invests in the future. It's got a lot of things to love: arrow functions, spread operator, classes, modules, things that make working with the language more enjoyable, even if it's not as advanced as some of the other options. I've looked at ClojureScript, which you're writing essentially Clojure, which is a Lisp-like language, so it's parentheses everywhere. But it is very powerful, but it's pushing you down a way of thinking, and I don't have a team that knows Clojure, that knows Lisp that well. So while it does a lot of really neat things, and there's some really great libraries for it, and the people that make it are utterly brilliant, the ramp-up time for us getting into that space was too much for what we needed to do. But that's something that each of you would need to evaluate and work with your team to sort out. This is just our choice. Now, once you've got your language sorted, what you're going to be writing most of your code in, now you have to invest in great tooling. This is a huge place for bang for your buck. If you do good tooling, you will make everything else you do easier. I guess it was a year or two back, I sat down and wrote, I took an afternoon and just wrote a bunch of tooling around certain kinds of projects we have to stand up a lot. And it scaffolded the project, it set up the database, it connected to the server, installed all the packages, did all of these things, and it was something I did manually every project we had to do. I just turned it into a script, made some tooling around it, documented it up a little bit, and when we sat down to figure it out, I think in total it saved the company between $50,000 and $60,000 at this point, which is not bad for an afternoon. That's pretty good. I was, in result, pretty happy with it. And I would say every time you invest better tooling, you'll get really amazing returns. The best setups have the tightest feedback loops. Let that sink in. That's the big point. The more quickly you can go from an idea with code to seeing it, seeing if it works, playing around with it, that's the thing you're after. That's the thing you're chasing, making it utterly easy to change things and see what you're doing. That maintains a flow state in your developers, in the people that are working with you. One-click is great. One-click installer, one-click setting this up. No-clicks is even better. Things like hot reloaders, stuff like that, they can be a little bit of a pain to set up the first time, and they do add some complexity, but every time I've taken the time to set up things that hot reload the page as I'm editing and changing the code, the better it is. It's been great. Automate freaking everything. If you do it more than twice, automate it. Write a script to do it for you. It's less error prone. You can test it. There's like no bad there at all. Bootstrapping, setting up somebody locally to work with the code base so they downloads their various libraries. Building, including source maps. Make sure your source maps are being made right. If you're not familiar with source maps, the idea there is that if you're using either a transpiler or something that compresses your code, if you have a source map, then when you're getting errors in your code, the browser can look at the source map and determine where in the pre-squished code or pre-transpiled code your bug is. It makes, quite frankly, it makes it possible to work with transpilers and with packed code in a browser. So make sure you get source maps working properly. Testing. Testing is not fun. I don't know anybody who enjoys it. Writing unit tests. I would love to find that person and lock them in a room. Really just, it's not fun, but it's really, really important. And setting up good unit tests, setting up a good framework, making it so it runs automatically is very important as you're making particularly large code bases. Deploying your code, making it so that actually putting it up on the server and testing it there is super simple. And then document the crap out of your tools. Utterly document the crap out of them. We try to make it so that people have to put jokes in the documentation. We try to make it fun. It sometimes works, sometimes doesn't. I do a lot of bad dad joke puns and stuff like that. I think my favorite was still, what is it? What stays outside all summer and is Irish? Patio furniture. Yeah. I put them in the documentation to keep me writing and to hurt other people. But it's, it makes it more fun, and it's important to get that really good documentation for the tools that you write, because that's what's going to save you a ton of time. What do we use? We use Webpack. Grunt came out, and it was sort of the first tool. It was about configuration. Gulp came out, and it was about streams, passing your information through streams. And then I would say Webpack and Brunch, which is even more recent, came out, and their whole thing is, we're mostly building the same kinds of things, so include the batteries. Like, make it easy to get going. And I did a bunch of work trying to get Gulp going with the rest of our tool chain, and I was downloading things I didn't understand, Vinyl, Source Stream, and generally a whole bunch of other libraries that I didn't know what they were doing to get everything to work, and I didn't like that. With Webpack, it's not quite as philosophically pure as Gulp is, but I felt like we've been able to get up and running with it more quickly. The other thing with it is that we use Babel, and Webpack is really easy to connect to Babel. We've been very happy with the result there. Now, getting into how you choose what you choose for your libraries. First thing is, what's the philosophy? What are these things trying to actually solve? What are they trying to do? Because it would be nice if Angular and React and Backbone and Ember were like comparing like all apples. But it's apples and engines and platypuses. Like, they're not the same thing. They're not trying to do the same thing. They all have their own unique philosophy and what problem they're trying to solve. For anything you're evaluating, try to figure out what is the core idea. What are they trying to do? Then you can evaluate if they're actually sticking to that, right? But every good library I have ever found is actually based on a philosophy. Figuring out what that philosophy is one of the first things you should do when you're evaluating some library. Then, can they explain it? I have found libraries that I was kind of interested in, and I went to go read the web page for it, and it was entirely opaque. I had no idea what it is. So, what was it? I was looking at one which was reactive extensions for JavaScript, which came out of Microsoft, and I went to a page trying to understand what they meant by reactive extensions, and it said something like, what was it? Observables plus link plus schedulers equals Rx. That meant utterly nothing to me. So that was a problem. Can they explain what they're trying to do to a lay user? If they can't, then there's a decent chance the documentation isn't going to be up to snuff. Then, and this is really important, what is their inspiration? The best libraries will tell you what they're coming from. What birthed this idea? Because then you can go back into their pedigree and go see if, hey, are they doing what they say they're doing? Is the thing that they say is their inspiration actually better? What problems are they solving from it? Good libraries will tell you where they came from. And it's awesome because from that, you then go back and find tons of other great stuff. Are they solving your problems? They might be solving their problems, but those might not be your problems. I cannot tell you how important this is. When somebody goes and learns a tool set like Angular or like Ember, it ends up becoming that whole, when all you have is a hammer, everything's a nail, right? And you just want to hit everything with Angular. And that's fine. There are certain things you can definitely solve with that. But understanding what your problems are means you can go build a whole tool chest of things to use. I'll use Angular sometimes. I'll use Ember. I'll use Backbone. What's appropriate for the thing we're trying to do? And then, does it play well with others? You're picking a library, not a cult. This is important. Like, I like a lot of the stuff that, say, like Meteor does, but Meteor is a all-in-one server and client thing. And I don't necessarily trust that all the time. I don't trust that when you're trying to solve all of the problems that you'll have all of the best solutions. I come from a strong Unix background, and the idea behind a lot of Unix tools is little solutions that all click together Voltron-like. And who doesn't like Voltron? So, really finding libraries that play well with others is exceptionally important. Then there's just the argument of small versus big. Are you going to click together a lot of little small libraries or small-ish libraries, or are you going to go for an all-in-one solution, something that tries to solve almost everything you need to do, with plugins as well, but where you're staying sort of in this one ecosystem the whole time? The fact of the matter is that monolithic big libraries, Angular, Ember, stuff like that, they do offer consistency. And if you're building something with a big team, that can be really important. We built a couple of Angular projects successfully, and I feel like they worked best when we had a lot of people contributing because it helped keep everybody down the same path. If nothing else, just here's the documentation. Here's the core of how you do what you do. Okay? It's becoming a bit of more of a mess with Angular 2. Like, let's say, hey, let's rewrite this whole thing. But we haven't fully gotten around to evaluating where Angular 2 sits. I don't love it so far, though. But centralized documentation, that's great. If you're using Ember, go to the Ember docs. That's cool. If you're sticking together a bunch of little libraries, there's a bunch of places where you have to go look up stuff. The quality can be different. How you find things in the docs can be different. That is an issue. When you are working with a great big library, there is some reduced flexibility. They say when you look at Angular, you look at Ember, the big guys, they're like, oh, you can swap out any of the parts. But there usually isn't great documentation for doing that versus using the things that are all built in. So you do have some reduced flexibility. And there is a larger mental load. Getting somebody up to speed on a smaller library is easier than a larger library. It's absolutely the case. You're also going to have less people that know a larger library than may know different smaller ones. That's why jQuery is so ubiquitous. While it's not tiny, what it does is fairly well defined. Then getting into documentation. Evaluating docs is, I'm weird, I like reading docs. I read technical documentation all the time because I'm really fascinated with how people build things. And I get a lot of weird looks from my wife when I've got the laptop in bed and I'm like, oh, at like 12 in the morning reading docs about, some Elixir library. Like, I enjoy it, and I think it's been a really valuable thing for me. I'm glad I do. I don't know, I think it'd be hard if I didn't. But the fact of the matter is you can have a really great piece of software that has really bad documentation. It is now a really bad piece of software. If you can't figure out how to use it and then how to share that with other people and get them on board with what you're doing, it's not good. And that's hard because I've seen some really brilliant software out there that didn't have good documentation, so I couldn't recommend it because getting everybody on the same path is too hard. You can't just say, go read the code. It's not reasonable. Unit tests. I consider this in many ways a kind of documentation. You can go read the unit tests for an app and find out a ton about it. Where their coverage is, how they think things should work, what they see as the sort of important breakable bits if they don't have full coverage. And then, read the docs. Read them all if you can. I have benefited a huge amount by, if I'm going to go read a library, I break open the docs, I get a notepad, I take notes, and I build stuff. I play around and I build stuff as I go. And then, read the code. If it's important, if it's something that your company, your group, yourself is going to use as the basis for something you're going to build, get under the hood. Go see how it works. The fact of the matter is there's a lot of really smart people out there writing JavaScript code right now, and there's a lot you can learn just by going in and reading the code from these big libraries. A while back, I sat down and read most of the code for Lodash and learned a ton. There was all kinds of neat techniques they were doing and just really clean ways of writing code that I really enjoyed reading. The other thing about all of this stuff with documentation is it also signals a really important point, which is that they're serious. This isn't just a kid in his bedroom. This is an important piece of code that they've spent the time doing the boring crap, doing the unit tests, doing the documentation. Functional programming. This has become a thing for me. Douglas Crockford wrote something back in 2001. He said, JavaScript is Lisp in C's clothing. And when I found that a couple years ago, it really spoke to me. I said, oh, that's an interesting approach to this. I am intrigued. And I've fallen into the functional programming hole. I like things that prefer functions. I like immutability. I like one-way data binding. I like chaining of things together. I like reactivity. If you guys haven't learned about that, it's taking events, and rather than a single event, you create event streams, and you can then process through them. There's a lot of really interesting stuff there. So in my mind, the best libraries in JavaScript tend to embrace the ideas of functional programming more than that of object-oriented. They embrace these ideas thoroughly. And I would say if you're learning and getting more deep into JavaScript, these are the kinds of ideas that I think will power more and more careers and making more and more cool stuff. So what did we choose through all of this? We chose a combination of Lodash, React, and Redux. Lodash is a functional tool belt. It was branched off of Underscore. One of the things I really like about it is it's got a build tool that lets you build just what you need. So you can make as part of your build process something that pulls down just the functions from Lodash you need. It's really about functional things, working with arrays, filtering things, map, reduce, all of that kind of fun stuff. React for the view. React has become a huge thing over the last a year or two, and we've been really happy with the ideas behind it. The core thing is that talking to the DOM is slow, and doing DOM manipulations is a pain in the ass. So it creates what they call a virtual DOM, and your components always write out all of their HTML. They create all of it every time. But under the hood, React is taking the DOM that you're outputting each time, comparing it to this virtual DOM that it has in memory that it's created, and then only making the changes it needs to the actual DOM in the browser. This ends up making really readable code that's still quite performant. It's not as performant as raw DOM manipulations if you do them right, but it's incredibly performant for what it is. Redux is essentially a functional back end for doing your models and doing your data and events and things like that with React. We looked at the Flux architectures and all that kind of stuff and ended up being really happy with Redux. In addition, we use React Hotloader for automatically reloading the web page. Been really happy with that. Now, that's sort of our general structure of what we chose to build for our single-page applications, our SPAs. The thing is there's lots of options from the different big boys that are out there that you can go and evaluate and check out for yourself. Zepto can do a large amount of what jQuery does for a much smaller size. However, if you're on a public-facing site and you're using jQuery from a CDN, jQuery basically costs you nothing, because the user probably already has it cached. So it's one of those things to kind of keep in mind. Like, yay, it's nice to have a really small thing with Zepto, but if jQuery's close to zero cost, it's hard to say. It is fast and it is tiny. So if you're doing things on mobile, it's a pretty good choice. Riot is a simplified, minified React. It does a lot of interesting things with doing things other than JSX, which is how React does a combination of JavaScript and HTML. Vue, I would say, would be a replacement for Angular and Ember. It's a full stack how you build apps. I'd say it's more functional than either of the two of those. I believe it does one-way data binding, which is, in my mind, better than two-way, less messy, easier to think about how it works. And then Meteor, it's an option, and it does everything. If you build with Meteor, you're building a front end and a back end kind of all in one, which is, depending on what you're building, it can be pretty damn neat. Then there's other great libraries out there. There's things that I really do enjoy working with. When I'm doing specific things, these are my go-tos. D3, I could give a whole talk and probably screw it up about D3. If you're doing anything with data visualization at all, learn D3. Even if you never use it in anything, you will be smarter just by learning how it works. It is brilliantly designed. It can be hard to get started with it. It's so powerful that there is a learning curve there. The documentation is okay, but you learn even more reading through the examples because the guy that made it has created really good examples that are very, very well documented. But yeah, D3, learn it. It's great. It really is. Paper, if you're working with SVG and vector graphics, Paper is excellent. It makes doing things with vector graphics in the browser a lot easier than sort of raw manipulations. If you do things in D3, you end up having to learn SVG and how SVG works if you're wanting to do graphics. So it's still good to learn how to do SVG manipulations, but Paper makes it really easy if you're just drawing graphics or really simple things. Socket.io smooths over a lot of the bumps having to do with real-time comms if you're doing WebSockets. Moment makes dates and times super simple. And then Super Agent for doing Ajax. Last thing I'm going to say, you can't stop swimming. Sorry. This is a process you're going to have to do again and again and again. You cannot pick a winner. You have to keep evaluating. You have to find works for you, and then never stop for searching for something better. That's it. Thank you very much.
Can you turn me on?
Like I said, I'll be over there at the Influxus booth most of the time now if you have any questions. And if you want to play the game, go.nasa.gov/spaceforensics. Thank you.